Hi, we are going to try something a little different today. This is an ever-evolving process, so I apologize if it is horrible. Since there's a lot of writing and drawing involved here, I do not want to do that all on my whiteboards, so I'm going to do it on here. And as I'm saying this, I'm realizing I could be doing it up there, and so next time I might try that. So, we've got zombie problems. We are talking about percents, and I've kind of alluded to percents in the past when I've asked you to convert decimals to fractions, fractions to percents, things like that. Big thing that you need to be clear on is percent is out of 100. So most of the fractions that we talk about, you could turn into a fraction out of 100, and you could use that to then simplify and help with percents. So this is a situation. The apocalypse has come and the zombies have arrived. Locked in our building are 210 students. The infection is spreading. Who will survive? I didn't mean for that to rhyme, but it kind of does. Day 1, 20% of the population is infected. They are now zombies. I need to use this zombiometer to show visually what's happening and how many students are now zombies and how many students are still living. So looking at this, I want to try to find a way to compare 210 students, which is my whole population, and the 20% that I'm going to need to zombify, basically. So a lot of students noticed that 20% was the same as 1/5. So they decided to break this zombiometer into 5 pieces, like so, and then label those so that we kept track of all of our percents. And I'm going to do that on the bottom of my percent bars. You could do it on the top, but this is a way for me to keep it organized for myself. So as you're going across, the zombiometer is getting worse up to 100%. On top, I'm going to talk about my population. So I have 210 people, and I need to figure out if I'm turning 20% of them into zombies, what's going to happen here? Well, we've done most of the work already. By figuring out that 20% is 1/5, we know we need to break 210 people up into 5 equal pieces. So I could do 210 divided by 5. And that is going to be 42 people. That means that in each of my chunks of 20%, I would need to have 42 people. And you could keep going all the way down, but all I care about is up to this 20% right here. Okay? So 20% of 210 people is 42 people, who are my new undead. And that means my still living is 210 minus 42, which is 168 people. Notice 2 things. 1, my whole population is the full bar. That is a whole. Also, 100% is the full bar. It is also a whole. So my whole quantity, whether it's people or something else, needs to correspond to 100% always. So now we come down to day 2. Well, the population is not the same anymore. We only have 168 people who are still alive. So my new whole would need to be 168 people. And I know that that is 100%. That's the first thing you could set up in your percent bar. You know your whole, you know it's 100% of the population. 25% of the remaining population is infected. Even more quickly than with the 20%, people were like, 25 cents, it's a quarter. I can turn that into 4 pieces. So they broke it down into their 4 parts and went up by quarters, 25%, 50%, 75%. So what remains is we need to figure out what would be one of those quarters of 168 people. Well, like here, when we had 5 parts, we divided by 5. Now that we have 4 parts, we would need to divide by 4. 168 divided by 4 is also 42 people. Look at that. Which means that each one of these would be 42 people. 42, 42. And I'm only interested up to 25% of the population, which means, once again, 42 people become zombies. And I had 168, and I need to subtract those 42 zombies to get my living population, so I would have 126 people who are still living. Alina got very excited about this until she realized that she was talking about how many people have become zombies. So, awkward. Now, day 3, 60% of the remaining population is going to become infected. Rinse and repeat. It's now the same idea. We should be getting pretty comfortable with how can we break down our whole and what percents would be useful here. So my whole is 168 people, and that is 100% of my population. So I can set my percent bar up. Then if I need to talk about 60%, a couple different ways students did this. Some people broke it up into 10%. Some people broke it up into 20%. Since we already did 20%, I'm going to do 10%. So if I want to go up by 10% each time, I'm going to need 10 boxes to get up to 100%. And I want to pay attention to my dimes, basically. Badrian said that she thinks of this as dimes going into $1, which I think is really a good idea when you're talking about 100%. And I actually only need to get up to 60%, so I could stop labeling, but I could keep going if I wanted. So when we had 5 pieces, we divided by 5. When we had 4 pieces, we divided by 4. We have 10 pieces. Let's divide by 10. 168 people divided by 10. That's not. I also did something wrong. 126. Oh, I'm so wrong. Scratch all of that. 126 is my population. 126 people divided by 10, not going to be a full human being. Fortunately, if we're thinking about zombies, sometimes there are body parts that fall off. So in fact, we have a part of a person, would be 1/10. So 12.6 people would be 10%, but I need to get up to 60%. So I can just do this 6 times. Shade it in. And that means I could do 12.6 times 6, which would end up being, I think we figured out that was 75.6. That seems right. That would be 75.6 people. So a lot more zombies. And that leaves our still living 126 minus 75.6, which ended up being 50.4. 50 and 4/10 of a person. Big takeaways here. When you're looking at the percent, how can you break your percent bar down so that it's going to easily go into that percent? When we were talking about 20%, it's useful to think about fifths, 20%, or 10%, because 10%, 20%. When we were talking about 25%, it was useful to go 25%, 50%, 75%. You could have also broken it down into 5%, so 5, 10, 15, 20, 25%. If you did that, then you would need to have 20 little pieces. That would each be 5%. Here, you could have done 20%, because you could go 20%, 40%, 60%, or you could do 10% and do 10% 6 times. So it comes down to reasoning about that. The other thing is you need to think about your whole is always 100%. So like, what is the whole? That is 100%. We'll do one more. It's pretty similar. We've got 40% of CGW's population. So right away, if I hear 40% and I want to get up to 100%, 2 options that I'm thinking about, I could do 10% and go 10, 20, 30, 40, or I could do 20% and go 20, 40. Since we did 10% here, let's do 20%. So I'll break it into 5 pieces. 20%, 40%, 60%, 80%. Notice that I haven't done anything with the population yet. I was able to set my percent bar up just from the percents. Now I can look at the number of students, 180 students. So that's my whole, 180 people. And I know that 40% of them are going to be zombified. So let's figure out what one part would be. 180 divided by 5 pieces would be 36 people. And that means that each of my pieces is going to have 36 people in it. And that means if I want to get up to 40%, I would do 20% and then another 20% to get 40. So I could shade those in. And altogether, that would be 72 people. So I would have 72 people. Sad, not a good day for CGW or UCW. Then students worked on a space race where they started finding that they might have to break things up into increments of 5%, increments of 2%. Some people were even breaking things up into 1% increments. You could always just divide by 100. And we are going to continue working with that tomorrow and think about how we might be able to generalize that moving into next week. So that's what I've got for you. Definitely use the percent bar tonight. I even say, but who knows, some of you may not read it. Draw a percent bar for each one of these. I do not just want to see a number. I need to see that you have modeled it and visually shown how you got that percent. All right, have a good night.